This is the notes for Unit 5 rotations. So far with our transformations, we've talked about a reflection, which is when I flip it over, and then a translation, when we slide it over, and then the last one is a rotation. Okay, so rotation is when it can be rotated less than a full turn around a point that's position is similar to the original. So as I spin this shape, every time as I turn it, it's going to start looking the exact same shape. Okay, so as I keep rotating it, keep in mind it's less than a full circle. So one way I could split up this picture would be if I went from, let's say, here to here. As I spun it, then it would turn out looking exactly the same. So every time as I keep turning it, I have rotational symmetry. So when I get done, I spun it 1, 2, 3, 4, 5, 6 times around. So that's why they said it has the center of rotation and 60 degrees of rotation. A full circle would be 360. So if I did it 6 times, each individual turn would be 60 degrees. Okay, so keep in mind, it's less than a full 360 every time. And then each time I turn it, that's what I divided by. So I could have also split up the picture, let's say through the dots. As I turn it, as I turn it, as I turn it, it's going to keep looking the same. So from here to here, from here to here, from here to here, every time it looked the same, but I could still spin it just 6 times. So we would say it has 60 degrees of rotation. Okay. Another thing to keep in mind, the center of rotation, right, that's where I'm turning it around. The number of degrees is how much I'm spinning it. And then if you go this way, that is opposite the ways of the hands of a clock. So they went 30, 45, 60, they were spinning it this way. So we would call that counterclockwise. Okay, so if I'm spinning him to the right, this direction around, those are like the hands of a clock. So that's clockwise. If I'm spinning him like in this example, where you spin him to the left, we would call that counterclockwise. Okay. So every time a full circle is 360, I'm going to spin it however many times. We're going to divide 360 by that number. Clockwise would be to the right like the hands of a clock. Counterclockwise is when you turn them to the left. All right, let's try some. So down here, we have 3 different shapes. Every time my center of rotation is going to be in the middle of my shape, and then I just like to draw a bar between each one as I rotate them. So like from here to here, I could spin it and I would get the exact same picture as from here to here. I'd get the exact same picture as from here to here. So as I keep turning him, I always want to get the same shape. They're congruent, so it should look the exact same. 360s in a full circle, and then I spun him 1, 2, 3 times. So my degree of rotation would be 120 degrees. Okay. All right, next let's try the snowflake. So if I put my center of rotation there in the center, I'm going to split up my big snowflakes. And every time as I spin him, he would look the same. This portion of my circle looks the same as this portion, looks the same as this portion. So I'm taking 360 degrees, and I could spin him 1, 2, 3, 4, 5, 6 times. So the degree of rotation is 60 degrees. The last one, a little trickier, I could go off of these, but then keep in mind those little small parts of the hubcaps wouldn't quite match up. So this time when I turn him, I'm going between the smallest detail there of my picture. Okay, so if I rotate him from here to here, I would have had half of this little hubcap and then not in the next picture. So I can't rotate it too many times. It has to, every part look identical. So between each of these dots in the center, that's where I have my center of rotation. I need this entire picture to look identical to this entire picture over here. To look identical to that entire picture over there. Okay, so I'm going off of that smallest detail there in the middle. If I rotated it from the top, these would not have lined up. Okay. So then again, we're taking 360 divided by 1, 2, 3, 4, 5 pivots. So with my calculator, we're going to do 360 divided by 5. So every time, 360 divide by however many you get. You can use a calculator. It may not be pretty sometimes. It's okay to get a decimal, and you can totally use your calculator. Okay. All right, so let's go ahead and flip it over then. So we got our degrees of rotation. That's how many times I can spin it. The other type of example that we're going to look at today is when it's on a coordinate grid. Okay. So in the very first picture, it says what type of rotation is shown. My cue is that F went from being on the top of the picture to now he's over here on the side. If I had done a translation and he had slid up, F would have still stayed on the top. Okay. If I did a reflection and I flipped him over this x-axis, F would have been on the top and would have gone to the bottom, which looks like it's a possibility, but then when I consider G, did G get flipped over to the top? No, G's over here on this side. That's why I know it's a rotation. Okay. Same thing with, let's say, for the letter E. E went from being on the left side of my picture to now he's on the upper right. So that's my cue that I was spinning this shape on his side. Okay. The small detail is, did he go clockwise, which is this direction, like the hands of a clock, or did he go counterclockwise and go backwards? Okay. So my F, the original one, was down here. The one that has a little tally, this is the new one. Okay, so as I went from F to the new F, I'm spinning around 0, 0. So I'm spinning in this direction. And I know that's a fourth of a circle, so that's 90 degrees. So he's spinning in a clockwise direction, and he's going 90 degrees. Okay. I can do that same thing for each ordered pair if you want. So like from G to this is now the new G. We went from here to here. Again, that would be 90 degrees. He got spun on his side, so it didn't get turned all the way over. So 180 degrees would be up here. If he was flipped halfway over on his side, we're spinning him 90 degrees. Okay, just be careful. This is the original one. This is the new one. So that's why I said he was going clockwise. All right, and let's try one here on our own. So start to finish. Let's start with how you guys are going to do it today in the activity. We're going to give you some ordered pairs. Just like the last 2 days, I would start with labeling my ordered pairs. So A is at -3, 1. C is at +2, +2. And then D is at 0, 0. Okay. Then our directions say 180 degree rotation. So if I went 90 degrees, he would end up over here on his side. 180 degrees is going to totally flip him upside down in his head. Okay, so it doesn't matter this time if I'm going clockwise or counterclockwise. 180 is going to flip him all the way upside down. Okay. So notice last time, when I went from the original G to the new G, we made 90 degrees. We're going to do the same thing here. From A to the new A should be 180 degrees, which is half of a circle. So we're looking for a straight line. So instead of going to the left 3 and then up 1, I'm going to go to the right 3 and then down 1. There's my new A. So that A with a little apostrophe. Instead of going to the left, we're going to go all the way to the right. And then instead of going up, we're going to go down. So it's going to spin him all the way around. Do you see how this is a straight line? And that's making 180 degrees. Okay, let's try that same thing then with C. So instead of going over 2 and then up 2, I'm going to go back 2 and then down 2. All the way from C to my new C would spin him 180 degrees around. So instead of going to the right, we went to the left, and then instead of going up, we went down. So each time my new ordered pairs should do the exact opposite. I'm going to end up with, instead of something in quadrant 2, I end up all the way here in quadrant 4. Or instead of 1, I'm going to spin them upside down, down there to quadrant 3. So So this is the one, the new one, has that little tally mark. For our last one, D, there's no such thing as spinning or flipping or translating, right? We're just leaving 0, 0 there alone. I didn't flip him over or spin him. He's just staying at 0, 0. So there's my new triangle. I got the exact same picture. It appears like it could be a reflection, like it could have got flipped upside down, but we know that it went from A to the new A and C to the new C, so that's why we say it was a 180-degree spin. Okay. As you're labeling them today, our rule then is I flip the X and I flip the Y. So instead of going to the left and then up, we went to the right and then down. That spun him 180 degrees around on his side.